Okay, let's spend some time on question 32 of chapter 2. Okay, so in question E, okay, in order to answer the question, okay, to determine the percentage of households from the South region that have a household income of $100,000 and over, okay, so we should convert the original table, okay, into cross tabulation of raw percentages, okay, in order to find the percentage of households from the South region that have a income of $100 and more, okay, $100,000 and more, okay. So first we convert the original table into raw percentage, and then we can find, okay, the South region, okay, whose income is over $100,000. Okay, the other question of question E asks, okay, the percentage of the households in the South region, okay. Oh, sorry. Okay, the other one, okay, it asks, hold on. Okay. Okay. Yeah. The other question, if it asks you, okay, so above $100,000, okay, what is the percentage from South? In that question, we should convert the original table into column percentage, okay, and then we can find, okay, for above $100,000 annual income, the percentage from South region. Okay, so from the raw percentage, okay, it shows that 17.57% of the households in the South region have a household income of $100,000 and more. Okay, and from the column percentage, okay, it shows that 32.25% of the households with a household income above $100,000 are from the South region. Okay, so if he asks you a question, okay, first the precondition is based upon the annual income, and he asks you the percentage from a particular region. We convert the original table into column percentage. Okay, in this question, okay, it asks us, okay, the precondition is region. Okay, precondition is region, and it asks us the percentage, okay, from a particular household income. Okay, so we should convert the original table into raw percentage. Okay, and then we can find, okay, so from the South region, about 17.57% of the South region, okay, their income is above $100,000. Okay. So that's how we use cross-tabulation table to summarize data for two variables. Okay. So we use the cross-tabulation table. Also, for the charts, we can use the scatter diagram. Okay. In a scatter diagram, okay, it explores the relationship between two variables. Okay. And after we draw the scatter diagram, we would like to draw the trend line that can indicate the relationship between the two variables. Okay. For example, in this chart, okay, we draw the value of x, okay, on the horizontal axis, the value of y on the vertical axis, okay, and then we depict the value, okay, for x and y. After that, we draw the trend line. Okay, it seems that as the value of x increases, okay, the value of y increases as well. So there is a positive relationship between x and y. In this diagram, okay, it shows that when the value of x increases, the value of y decreases. So there is a negative relationship between x and y. In this diagram, when the value of x increases, the value of y stays at the same value. Okay, so we just draw the horizontal line that just tells us there is no relationship between x and y. Okay, this is example of Panthers football team. Okay, and they would like to use the scatter diagram, okay, to point out the relationship between the number of interceptions and the number of points scored. Okay. And then we just draw the number of interceptions on the horizontal axis. That's the value of x. Okay. And y represents the number of points scored. We draw that on the vertical axis. Okay. So it seems that there is a positive relationship between the number of interceptions and the number of points scored. Okay. So the more number of interceptions, the higher the points you scored. Okay. So that's how we draw the scatter diagram and trend line. The trend line just indicates the relationship between these two variables. Okay. So we can get insights from the previous scatter diagram and trend line. Okay. First, it indicates a positive relationship between the number of interceptions and the number of points scored. Okay. Higher points scored are associated with a higher number of interceptions. Okay. The relationship is positive. Okay. And another chart we can use to depict the relationship between x and y. We use the side-by-side bar chart. Okay. So we depict multiple bar charts on the same display, and each cluster of bars represents one value of the first variable, and each bar within a cluster represents one value of the second variable. Okay. Remember the home style example. Okay. There are 4 styles of home, and we just use $250,000 as the critical value. Okay, so some homes are priced below $250,000. Some of them are priced above $250,000. Okay, we can use the side-by-side bar chart as this. Okay, on the horizontal axis, we show the home style. 4 home styles: colonial, log, split level, and A-frame. Okay, on the vertical axis, we just show the frequency. Okay, and the light gray color, this bar represents the homes that are priced below $250,000. And the other one, the dark bar just represents homes that are priced above $250,000. Okay, so for colonial, as you can see that more homes are priced below $250,000. For the log, more homes are priced above $250,000. For the split level, more homes are priced below $250,000. For the A-frame, more homes, way more homes are priced below $250,000. Okay, that's how we use the side-by-side bar chart, to depict the relationship between 2 variables. Okay, another one is the stacked bar chart. Okay, that can also help us to display and compare 2 variables on the same display. Okay, and the bar chart. In the bar chart, each bar is broken into rectangular segments of different color. Okay. So still we use the home style example. Okay. For the colonial, out of 100 sample size, 30 of them are colonial. So out of the 30 colonial homes, 18 of them are priced below $250,000. And the other one, 12 of them, 12 of them are priced above $250,000. Okay, so we draw colonial in the same bar, but we just classify this bar into two different segments. One of them is priced below $250,000. The other one is priced above $250,000. For the log, so out of 100 customers, 20 of them purchase log. So for the 20 log homes, 6 of them are priced below $250,000. 14 of them are priced above $250,000. And for the split, 35 of them, out of 35 split level, 19 of them purchased the split below $250,000. 16 of them purchased the split above $250,000. And the last one, A-frame. 15 people purchased A-frame. 12 of them purchased that at a price below $250,000. 3 of them purchased A-frame above $250,000. So that's the stacked bar chart. In this chart, we just draw a bar for a particular category, and then we use the different colors to depict the price range. We can also use the stacked bar chart to represent the home and the price range like this way. So first, we convert the original table into column total. So originally, 18 homes colonial are priced below $250,000. After we divided 18 by 30, it becomes 60%. And the other one is 40%. So that tells us that for the colonial homes, 60% of them are priced below $250,000, and the remaining 40% is priced above $250,000. And the log, the original table shows us 6 of them, 6 of the log are priced below $250,000. After we divide it by 20, it becomes 30%. So for the log, 30% of them are priced below $250,000, and the remaining percentage is 70% of them. 70% are priced above $250,000. And split, 19 out of 35. So we divide 19 by 35, and then we obtain a value 54.29%. And the remaining percentage is 45.71%. So for the split home style, about 54% are priced below $250,000. 45% are priced above $250,000. For the A-frame, we divide 12 by 15. Then we get 80%, and the remaining percentage is 20%. So for the A-frame home style, 80% of them are priced below $250,000, and 20% of them are priced above $250,000. So that's stacked bar chart. We can first convert the original table into column percentage, and then draw stacked bar chart like this. Or we just use the original table, and we use the same bar, but we divide it into different segments to represent the frequency and highlight the difference of price range. questions? Okay, so in order for us to represent, to display the relationship between two variables, we can use the cross tabulation table or the stack bar chart, side by side bar chart. And scatter diagram with a trend line. Okay, so that's the data visualization. We use graphical displays to summarize and present information about a data set. And here are some guidelines. We should give the display a clear and concise title, and keep the display simple. Clearly label each axis and provide the units of measure. And we use distinct colors. And when we would like to use the multiple colors or line types, we would like to provide a legend. So the displays that we use to show the distribution of data, we can use the bar chart. The bar chart is used for to presenting the distribution for categorical data. Also we use the pie chart. That's also used for to show the relative frequency and percent frequency for categorical data. So two charts for categorical data, bar chart and pie chart. For quantitative data, we use dot plot, histogram, and stem and leaf display. So let me write it down on the blackboard. So for qualitative data, the chart we use, first one is bar chart. And the other one is pie chart. For quantitative data, we use histogram. And then the dot plot. And stem and leaf display. And in order to display the relationship between two variables, we use the scatter diagram. And side-by-side bar chart. And stacked bar chart. So these two charts help us to compare two variables. Also the scatter diagram. Yeah, scatter diagram shows the relationship. Okay. And don't forget, when we draw the scatter diagram, okay, we would like to draw the trend line. Okay, and a data dashboard, okay, is also a data visualization tool. Okay, it organizes and presents the key performance indicators, okay, that can help us to monitor an organization or process. Okay, so this is a data dashboard example. Okay, so we can use the bar chart, pie chart, okay, and the side-by-side bar chart, okay, or the histogram, okay, to present, okay, to address that issue, okay, by using these, okay, charts. So this is the data dashboard. Okay, so again, there are two types of data. Okay, categorical data. That's okay. In the other word, we also call this, okay, qualitative data. Okay, and quantitative data. Okay, so for both data, we use tables and charts. Okay, for categorical data, we use bar chart, pie chart. Okay, side-by-side bar chart, stacked bar chart. For quantitative data, we use dot plot, histogram, stem and leaf display, scatter diagram. Okay. To summarize the categorical data, the table we use, okay, which present the frequency distribution, relative frequency distribution, percent frequency distribution, and cross tabulation table. Okay. For quantitative data, okay, the table we use include, okay, frequency distribution, relative frequency distribution, percent frequency distribution, okay, cumulative frequency distribution, cumulative relative frequency distribution, cumulative percentage, okay, frequency distribution, and we also use the cross tabulation table, okay, to summarize the relationship between two variables. Okay. This is important. Okay. So any questions? Okay. So that's what we have learned from chapter 2. Okay. How to, okay, organize data. Okay. How to summarize data by using tables and charts. Okay. This is the homework. Okay. Question 27 and 43 of chapter 2. Okay. No, could you please take a picture of that? That's the homework for today. Okay, so 2 questions for chapter 2. Okay, that's your homework. Any questions? Okay, so we have finished chapter 1 and chapter 2. Now let's go to chapter 3. Okay, after we have collected data and we use tables and charts to summarize the data. Okay, and finally, okay, we would like to use descriptive statistics, help us to measure the numerical variables. Okay, and these measures, okay, include 2. Okay, the first one, the measures can help us to depict, to point out location. Okay, location. For example, what does average help us to measure? Average. If we, after the quiz or after exam, okay, usually we collect the information of each student's grade, okay, the score, okay. And after that, we would like to, calculate the average score. Okay, why do we need to know the average score? The average. Okay, and also if we go to Starbucks, okay, I believe that the CEO of Starbucks would like to know the average sales. Weekly sales or monthly. Quarterly. Annually. Okay. So why do we calculate average? A general trend. Okay. Also, finding a general trend, okay, of a particular variable can help us to analyze, okay, to analyze the score, okay, how good, okay, the class, okay, the class performance, okay, for a quiz, for the midterm, or for the final, okay. How about weekly sales, monthly sales, quarterly sales, and annual sales? That also help us to analyze, okay, the sales, okay, Starbucks performance, okay, maybe particularly during the pandemic, okay, before the pandemic, during the pandemic, and after the pandemic, okay. So if we use the location, what does average tell us? Location. Okay. So the average score, that's 60. Okay, some of the student scores are below 60. Some of them are above 60. Okay, for example, if the average score of this class is 65, what does 65 tell us? It tells us the location. Okay, so 65 is larger, it's higher than 60. So our class performance is better, okay, better than 60, because 60 is usually it is a critical value. It tells us that, okay, how if we have a score, okay, above 60, it means that we pass the course, okay. But if our average score, okay, is 65, it means that we not only pass the class, okay, our performance is better, okay, than the critical value, okay. So 65, the average score, the average weekly sales, monthly sales, quarterly sales, and annual sales, okay, tells us the location. Okay, so measures of location, we can use average, okay. And the other measure, okay, is variability. How do we find the variability? Okay, for example, if I purchase coffee from the Starbucks and I order, okay, a grande caramel macchiato, Okay, grounded. Okay, so the size is big. Okay, how big is that? Is it about 350 cc? Or, yeah, but usually when we purchase coffee from a store, okay, it gives us another value. It tells us that, well, the coffee we purchase from the store, it is not exactly 350 cc. Okay, it might be, okay, it might be 355 or 345. Okay, so what is this value tells us? Plus and minus 5. Yeah, it is standard deviation. Okay, so that tells us the variability. Okay, so we use the descriptive statistics, okay, to present the location of the variable, to present variability of this variable. Okay, so if the measures are computed for data from the sample, okay, we call that sample statistics. Okay, if the measures are computed for data from the population, okay, and these measures are called population parameters. Okay, and we would like to use the sample statistics, okay, to be the point estimator of the population parameter. Okay, so for example, if I would like to know the average height of the whole campus, but there are more, okay, 16,000 students in the campus. It is hard for us to, yeah, collect the data from each of the students, okay, of the CYCU. And the average height of CYCU is the population parameter. Okay, because it is hard for us to obtain the data for the whole campus, okay, instead of doing that, we just collect, okay, few observations and use that as the sample. For example, if I just visit, okay, this IUBM program, okay, and I just, okay, collect the height of each of you, each of the students of the IUBM program, and then I find the average height for our IUBM program. The IUBM program is part of the CYCU, and I use that, okay, as the sample, okay, and then I calculate the average height for the program. This is called sample statistics. Okay, so the main thing for statistics is to use the sample statistics, okay, to measure, okay, to see if the sample statistics is a good point estimator of the population parameter. Okay, that's the numerical measures. Okay, so again, the measures computed, okay, for a sample is called sample statistics. The measures computed for a population, then these measures are called population parameters. Okay, and sample statistic, okay, is referred to as the point estimator of the population parameter. Okay, then let's see the measures of location. Okay. In statistics, average, okay, we do not call average, we call that mean. Okay, so instead of calling average score, we call mean score. Okay, and the weekly sales, monthly sales, quarterly sales, and annual sales. Okay, after computation, we call that mean weekly sales, mean monthly sales, mean quarterly sales. Okay, so we call that mean. Mean is a measure. Okay, it measures the location. Okay, in addition to that, in this chapter, we will also learn how to calculate the weighting mean. Okay, for example, like your GPA. Okay, your GPA is after weighted. Okay, and the other one, we would like to calculate the geometric mean. Okay, we use that. Okay, to particularly, we would like to measure the growth rate of your return over a particular investment period. Okay, so we use geometric mean. Okay, in addition to this mean, we learn median, mode, percentiles, and quartiles. Okay, so this the mean, weighting mean, geometric mean, median, mode, percentiles, and quartiles. Okay, these are measures of location. Okay. Let's see the mean. Well, mean is the most important measure of location. Okay. The mean provides a measure of central location. Okay. The mean of a data set is the average of all the data values. Okay. And the sample mean, we would like to use the symbol, X bar. X bar represents the sample mean. For the population mean, the symbol we use is mu. Okay. So we would like to use the sample mean X bar as the point estimator of the population mean, mu. Okay. How do we find the sample mean? Well, given the sample size, small n represents the number of observations in the sample. Okay. First, we sum up all the values of the n observations and then divide the summation by the sample size, small n, and then we obtain the sample mean. Okay. Questions? Oh, Michael has questions. Okay, so that's how we find the sample mean. How about population mean? Yeah, we calculated the same way, but because now we calculate the mean value for the population. In the denominator, we use the whole population size. And the whole population size is the number of observations in the population. Okay, and we use the capital N. Okay, capital N denotes the number of observations in the population. Okay, so for the whole values in the N observation, we sum up all the values. Okay, and then we divide the summation by the population size, which is the capital N. Okay, that's how we find the population mean. Okay, and sample mean, we sum up all the x values of the small n observations, and the small n represents the number of observations in the sample. Okay. Questions? Okay, So let's see the book. Okay, page 109. Page 109. Equation 3.1. Okay, 3.1 gives us the, that's the formula to compute the sample mean. Okay. The denominator is the small n. Okay, that represents the number of observations in a sample. Okay, and then formula 3.2. Okay, to calculate the population mean, okay, the denominator is capital N. Okay, capital N represents the number of observations for the population. Okay, let's see this example. Apartments rents. Okay, 70 efficiency apartments were randomly sampled in a college town. Okay, and we have 70 monthly rents for these efficiency apartments. Okay, so that's the original data values. Okay, and then we would like to obtain the sample mean. What should we do? So we sum up the 70 monthly rents, and then divided by so there are 70 70 efficiency apartments. So in order to find the sample mean, I would like to find the mean monthly rent for the efficiency apartments. So first I sum up the 70 apartment rents and then divided by 70. 70 is the sample size. And then I obtain a value $590.80. Is it expensive? Yes, a little bit expensive. $590.80. If I convert it into, if it is in USD dollars, it is expensive. $590.80. If it is NT, if it is NT, it is good. Cheap, very cheap. So that's the how we find the sample mean. And then let's see the second measure of location, median. Median, in a data set, usually it is a value in the middle. In the middle, when the data items are arranged in an ascending order. So after I collect data, I arrange them from the minimum value to the maximum. That's the ascending order. And then I would like to find the value in the central location. In the middle, that's the median. And whenever a data set has extreme values, the median is preferred measure of central location. Because we are concerned with the value in the middle. And the median is not affected by the extreme value. But when we calculate mean value, if the mean value, the data set, there are some extreme values, then the mean value will be affected by the extreme value. So that's why we say whenever a data set has extreme values, the median is the preferred measure of central location. Questions? Where is Adley? Adley is not around. So can I ask you a favor? Could you please help me to clean the blackboard? Thank you. So let's take a 10-minute break. Okay. So median is the measure of location most often reported for the annual income and property value data. Okay. A few extremely large incomes or property values can inflate the mean, but for the median is not influenced or affected by extreme values. Okay. So if we are faced with an odd number of observations, okay, given 7 observations, okay, so first, in order to find the median, we rearrange the data values from the smallest to the largest. Okay, so the smallest value is 12, and then 14, okay, 18, 19, 26, 227s. Okay, so we arrange the 7 data values in an ascending order. Okay, and then we find the value that is in the middle. Okay, so okay, 7 observations. Okay, in the middle that should be 19. Okay, 19 is the fourth value. Okay, so it is now in the middle. It is the median because 3 values are lower than 19, and the other 3 values are greater than 19. So 19 is the median. That's how we find the median, okay, for an odd number of observations. Okay, there is a formula. Okay, so we add 1 to 7. Okay, so given 7 observations, we add 1 to that and divide it by 2. Okay, that's how we find the position of this value. Okay, so 8 divided by 2, that's 4. Okay, the position of the median, okay, is 4. Okay, the 4th position. Okay, and then after we arrange the data, okay, from the smallest to the largest, okay, we count first, second, third, fourth. Okay, that's how we find 19. Okay, so the value of the 4th position is 19. Okay, questions? Okay, now let's see if we are faced with an even number of observations. Even number of observations. Oh, lovely. Anna said, if you are worried, you can leave right now. Oh, okay. How about that? An even number of observations. Okay, say 8 observations. Yeah, 8 plus 1 divided by 2, that's 4.5. Okay, so it is a value between 4th and the 5th. Okay, so we should find the 4th value and the 5th value. Okay, and then we find the average, okay, of these 2 values. Okay, so the 4th value is 19. The 5th value is 26. Okay, we add it up, divided by 2. That's how we find the mean value, okay, of these 2. Okay, so first we find the position, okay, 4.5. Okay, that's the position. Okay, and then we find the average value of the 4th and the 5th position. Okay, so we add 19 to 26 and divided by 2, 22.5. Okay, that's how we find the median for the even number of observation. Okay. Questions? Okay, let's see this example. 70 monthly rents. Okay, 70 monthly rents. Okay, so for the value, we rearrange that from the smallest value to the largest. Okay, and there are 70. So to find the position, we add 1 to 70. and divided by 2. Okay, the position is 35.5. Okay, so we should find 35th and 36th. Okay, and then find the average, okay, of these two values. Let's find 35th and 36th. Where are they? Okay. So for each row, there are 10 observations. Okay. So 1, 2, 3, 4, 5. Okay. 575. That's the 35th. And 36, 575. Okay. Because both values are the same, the average of that 575. Okay. And how do we interpret that? Well, half the apartment rents are equal to or less than $575 per unit. And the other 5, okay, the other half, the departments, okay, rents are equal to or more than $575. Okay, questions? Yeah, in ascending order. Yeah. Questions? Okay. And also, in some cases, we compute the trim mean. Okay, what does trim mean mean? Okay. Well, when there are extreme values, okay, and then we just delete, we remove some of the extreme values and compute the mean of the remaining values, then that's the trimmed mean. Okay. For example, the 5% trimmed mean is obtained by removing the smallest 5% and the largest 5% of the data values and then compute the mean of the remaining values. Okay. For this example, a figure skating competition produces the following scores: 6.1, 8.1, 8.3, 9.1, 9.9. Okay. The mean for the 5 values, okay, is we add them up and divide it by 5. Okay. So the mean is 8.28. Okay. Now, if the question asks us to trim the mean by a total of 40%, what should we do? We remove the lowest 20% and the highest 20% of values. Okay, so there are 5 values. Okay, so each of them accounts for 20%. Now, we remove the lowest 20%. Okay, we remove 6. And then we remove the largest 20%. We remove 9.9. Okay, after that, there are 3 scores left. Okay, 8.1, 8.3, and 9.1. Okay, we add them up, divided by 3. That's 8.5. Okay, so a trim mean, okay, after 40% will equal 8.5. Okay, and before the trim, the mean for the 5 scores is 828. So there's a difference. Okay, there's a 0.22 points difference. Okay, questions? Okay, so after we trim the extreme values, we reduce the outlier bias, and we had the effect of increasing the reported average. Okay. Okay. Another measure of location is mode, okay, which is the value that occurs with greatest frequency. Okay. And the greatest frequency can occur at 2 or more than 2 different values. Okay. If the data have exactly 2 modes, the data are bimodal. Okay. It could be more than 2 modes, then we call that multimodal. Okay. From the 70 apartment rents, okay, after we arrange that in an ascending order, okay, which value occurs the most? Okay, 550 Okay, it occurs 7 times. Okay, so that's the value that occurred most frequently, okay, among the 70 observations. Okay, and then we call that mode for the apartment rents. Okay, any questions so far? Okay, now let's see the weighted mean. Okay, usually we calculate our GPA, okay, based upon the weights. Okay, so how do we calculate GPA? So for example, you are taking statistics, and that's 3 credit hours. Okay, suppose you obtain a 90 for the class. And are you taking investment? Oh no, which one? And what else are you taking? What courses are you taking right now? Oh, financial accounting. Accounting. Okay, let's say if you obtain 88, and also accounting is 3 credit hours. Okay. What courses are you taking right now? Financial management. Management. Okay, suppose that you obtain 87. It is also 3 hours, right? 3 credit hours. Okay. Let's say if you are taking 3 classes this semester, okay, and now you would like to calculate the GPA, okay, based upon the credit hours. How do you calculate your GPA? That would be 90. 90 multiplied by 3 plus 88 multiplied by 3. 87 and divided by okay, and that's how we find your GPA. But okay, that's the mean. But to convert it into GPA, it depends. Usually, above 90 should be 4, right? That's 4. And 88 is the 3. Okay, 3. And 80 is also 3. Okay, so to calculate the GPA, 4 times 3 plus 3 times 3 plus 3 times 3 divided by 9. Yeah, that's the way, okay, we calculate your GPA. Okay, that's based upon the weights. Okay, so it is a weighted mean. Okay. Okay. So in the numerator, okay, that's the summation, okay, of the weighted data values. Okay, so W represents the weight. Okay, weight for observation I. In the denominator, that's the sum of the weights. Okay, that's how we calculate the weighted mean for a sample. If we calculate weighted mean for a population, okay, then we should use the weight for population. Okay. Let's see the construction wages. Okay. So there are 5 types of worker. Okay. Each of them has the hourly wage and the total hours. Okay. So Ron is a home builder. Is looking over the expenses he incurred for the house he just built. For the purpose of pricing future projects, he would like to know the average wage, okay, the hourly wage he paid the workers he employed. Okay, and on the right, okay, here are the categories of workers, okay, Ron employee along with their respective wage. and total hours worked. Okay, so to help Ron to calculate the weighted mean, okay, like the carpenter's hourly wage is 21.60. Okay, the weight, okay, the weight represents the total hours, okay, which is 520 hours. So we multiply both, okay. And for the electrician, $28.72 multiplied by 230. Labor, $11.80, okay, multiplied by 410. Painter, $19.75 multiplied by 270. Plumber, $24.16 multiplied by 160. Okay, we add them up, okay, and then divide it by the total number of the weights. Okay, the weights again that represents the total, okay, number of hours. Okay, so the total number of hours is 1590. We divide $31,873.70 by 1590 hours. Okay, and then we obtain a value that's the weighted mean. Okay, 20.0464. Okay, that's rounded up to the second decimal point, $20.05. Okay, that's the weighted hourly mean. Okay, but if we do not, okay, calculate like that, we create, okay, each carpenter's hourly wage equally. Then the equally weighted mean, okay, is we just, okay, find the mean wage amount of 5, okay, 5 workers hourly wage. Okay, so we just add these 5 values up, okay, and divide it by 5. That's $21.21. Okay, so you can see the difference between these two. When we create, okay, the hours equally, okay, that makes the mean very, simple to calculate. Okay, that's only $21.21. But if we create, okay, the number of hours worked, okay, as an important factor, okay, we also account for that when we calculate the mean. Okay, then the weighted mean hourly wage is lower than the equally weighted mean. Okay, questions? Okay, so in order for us to apply, okay, for a better graduate program, okay, because the graduate school cares about our GPA, okay, so given so many courses we are taking, we should be working very hard on the courses that have, okay, 3 hours credit hour, 3 credit hours, okay, because that will definitely, okay, affect our GPA. Okay, we should work very, very hard on these courses, okay, statistics, accounting, and management, because all of them have 3 credit hours. Okay. Questions? Okay. And the final mean, okay, is called geometric mean. Okay. It is calculated by finding the nth root of the product of n values. Okay. It is used in analyzing the growth rates in financial data. Okay. For example, we'll use that to calculate our investment, okay, growth rate every year. Okay. So it should be applied anytime you want to determine the mean rate of change over several successive periods. Okay. Are you okay? I still worry about. Okay. Okay. So geometric mean, okay, is for us to determine the mean rate of change over several successive periods. Okay. So we should find the product, okay, the return, okay, rate of return every year and multiply them together and then take the nth root. Okay. And after that, we deduct 1, okay, from the average growth rate, okay, and then multiply it by 100%, okay. And what do we call it? This is the average growth rate per year, okay. Why do we deduct 1 from that? Because when we invest, okay, we should account for our principal, okay, our original principal when we invest. Okay, so after we deduct 1 from that, okay, we multiply it by 100%. Then we can find the average growth rate per year. Okay, so given the rate of return for a particular asset, okay, so in period 1, the rate of return is negative 6%. Okay, that makes the growth factor 0.94. Period 2, okay, minus 8%. The growth factor is 0.92. Period 3, rate of return, okay, negative 4%. Okay, that makes the growth factor 0.96. Period 4, rate of return is 2. The growth factor is 1.02. Okay. Period 5, rate of return is 5.4%. The growth factor is 1.054. Okay. And then we multiply the 5 growth factor together, okay, and then take the 5th root. Okay. After that, we get 0.97752. Okay, that's the geometric mean. Okay. And then we should deduct 1 from that, okay, because we should account for the principal we originally invest. Okay, we deduct 1 from that and multiply by 100%. Okay, that's negative 2.248%. Okay, and how do we interpret that? Well, given this rate of return, okay, on the asset, okay, that I invest for the previous 5 periods, okay, the average growth rate per year is negative 2.248%. Okay. Okay, so again, given the rate of return for each of the periods, okay, first we find the growth factor and then multiply them together, okay, and then take the 5th root. That's the geometric mean, okay. But in order for us to find the average growth rate, okay, per period, per year, okay, we deduct 1 from that and multiply it by 100%. Okay, now let's see this one. An investment of $100,000. Okay, so originally, okay, my principal is $100,000, but in the end of year 1, it goes down to $50,000. Okay, so let us say 50%. Hi. Okay. So let's go back to the investment. Okay. To calculate the mean rate of return. Okay. Every year. Okay. So I have invested for 2 periods. Okay. That's my investment period. 2 periods. Okay. But for each period, I have different rate of return. Okay, if I do not calculate the geometric mean, okay, I might think that, okay, for the period 1, okay, the rate of return, hello, okay, the rate of return for period 1 is negative 50%, okay, that makes our growth factor for period 1 is 0.5, okay, for period 2, the rate of return is 100%, okay, and then we add it to 1, that makes the growth factor for period 2 is 2. Okay. If we just calculate the average mean by looking at these 2 rate of return and find the average, okay, we might think our mean rate, our mean rate of return is 25%. But is that high? Is it that high? Okay. So if we look at the geometric mean, okay, find the growth factor for each period, okay, and then multiply them together. For period 1, the growth factor is 0.5. Period 2, growth factor is 2. Okay, we multiply them together because there are 2 periods, okay, and then find the square root of that, which is 1. Okay, and then we deduct 1. What is this 1? This 1 represents our original principal. Yeah, our original principal. Our original investment, original principal. Okay, so after the deduction, okay, actually the average rate of return per period is 0. So we have no gain, we have no loss, okay, per period. Okay, so you see the difference. Okay, so that is how we find the average growth rate per period. Okay, and this is the arithmetic, rate of return, arithmetic mean rate of return. When we calculate in this way, we inflate the mean rate of return. But if we use the geometric mean rate of return, it gives us, actually more accurately reflects the average growth rate per period. Actually, that's 0. It is not that high. It is 0. No gain, no loss. So when do we do that? When do we calculate the geometric mean of return? When we are calculating the average growth rate of return per period for the asset, for the financial asset, or when you are investing in a property, for a house or crop, we can calculate the geometric mean return. Questions? Okay, so that's the arithmetic mean rate of return, 25%. We just add these 2 rate of return and find the average. That's 25%. But when we calculate the geometric mean rate of return, actually that's 0%. So it more accurately present the result. The arithmetic mean rate of return might mislead. We might think that, well, our rate of return is good. It is looking good. However, the geometric mean rate of return tells us that, well, it is not as high as 25%. Actually, it is 0. Our average growth rate per period is 0. It is 25%. It is not 25%. Questions? Okay, so the geometric mean rate of return of the investment per year for the 2-year period is 0%. Okay, in the other words, the geometric mean rate of return of the investment for the 2 years is 0% per year. Okay, and this geometric mean rate of return actually more accurately reflects the zero change in the value of the investment per year for the 2-year period than does the arithmetic mean rate of return. Okay. Questions? Okay. Okay. Before that, okay, let's take a 10-minute break. And okay, so let me finish percentiles and quartiles, and then we will have a exercise. Okay, an exercise for today. Okay, and also 2 more questions for today's homework. Okay. Okay, let's take a 10-minute break. I will check attendance later. Okay, so for those who already left the class, okay, hopefully they already took the leave online. Okay. Okay, break. Okay, now let's see the percentiles. Percentiles also measures locations. Okay, and it provides information about the data are spread over the interval from the smallest value to the largest value. Okay, for example, if we would like to find out the admission, okay, admission test scores for colleges and universities, okay, we use percentiles. Okay, for example, okay, if Nonoka, okay, Nonoka's English is good, for example, and then your admission test score in CYCU is in the top 5%, okay, for example, okay, and in the top 5%, so that means, okay, in percentiles, Nonoka's admission, okay, test score is 95%, okay, 95% percentile. Okay, and Cai for example, Cai is also okay in the 95% percentile. Okay, so the p percentile of a data set is a value such that at least p% of the items take on this value or less, and at least 100 minus p% of the items take on this value or more. Okay, so for example, if your English, okay, is in the top 5%, okay, that makes you, okay, 95%, okay, and then you take on, okay, at least 95%, okay, of the scores, okay. So how do we find the percentiles? We should arrange the data in an ascending order first, okay, and then compute the percentile, okay, and we use LP. L represents the location, okay. P is the p percentile, okay. So P represents the percentile, okay, out of 100, and multiply by the sample size plus 1, okay. So go back to the 70 apartment rents. If we would like to know the 80th percentile, okay, the first thing to do is, okay, we rearrange the data in ascending order, okay, and then find the position, okay, where the 80th percentile is, okay. So we divide 80 by 100 and multiply by 70 plus 1, okay. The position tells us it is 56.8, okay. How do we find that? Okay, so we should find the 56th and the 57th value, okay. Find the 56th value plus 0.8 times the difference between the 50th and 56th values, okay. So the 56th is 635, okay. 57th is 649, okay. We add 635, okay, and then find the difference between 635 and 649. Okay, multiply the difference between these two values by 0.8. Okay, that's how we find the 80th percentile value, okay, which is 642.2. Okay, questions? Okay, so again, first, to find the 80th percentile, let's find the position, okay, 80 out of 100, multiply by the sample size. Sample size is 70 plus 1. Okay, and then it gives us the position, which is 56.8. Okay, so it should be a value. Okay, it is a value, but it is more close to 57th. Okay, it is a value more close to 57th, but it is not 57th. Okay, so to find that, we first find the 56 value, okay, which is 635. And then 57's value, $649. Okay, it should be a value very close to 649, but it is not 649. Okay, so how do we find that? Okay, first we add 635 to the difference between these two values. Okay, and then the difference multiplied by 0.8. Okay, that's how we find the 80th percentile value, 649. Oh, sorry, 646.2. Okay, so about 80%, okay, or more, okay, of the apartment rents take on the value of $646.20. Okay, but the other one, okay, so below 80%, or less than or equal to 80% of the apartment rent is below $646.20. Okay, so that's 80th, okay, percentile. So at least 80% of the items take on the value of $646.20 or less. Okay, and at least 20% of the items take on the value of $646.20 or more. Okay, so 80% of that, okay, are below $646.20, and 20%, okay, or more of the items take on the value of $646.20. Okay, questions? Okay, so that's the 80th percentile. Okay, now let's see the last one. The last measure of location is quartile. Okay, quartile, it just splits the data values into, okay, 4 segments. Okay, the first quartile, second quartile, and third quartile. Okay, the first quartile, actually in percentile, that's the 25th quartile. The second quartile, okay, that's the 50th percentile. Okay, and the third quartile, that's the 75th, okay, 75th percentile. Okay, so back to the apartment rent. Okay, how do we find the 25th percentile? Okay, 25th percentile, in other words, that's the first quartile. Okay, how do we find that? Okay, by using the formula, okay, 25th percentile. Okay, so we divide 25 by 100 and multiply it by 70 plus 1. Okay, which is 17.75. Okay, so we should find the 70th, okay, the 17th value and the 18th value. Okay, and from the slide, okay, both values, the 17th is 545, the 18th is 545 as well. Okay, but the position tells us that's 17.75, okay, position. So we should add 545. Okay, that's the 70th value. Okay, plus the difference between 17 and 18. Okay, because both values are the same, the difference is 0. Multiply it by 0.75. Okay, because these two values are the same, the difference is 0. Okay, 0 multiplied by the value is still 0. Okay, so the 25th percentile is 545. Okay. Questions? Okay, now let's see 50th. Okay, how do we find 50th? Okay, 50, yeah, out of 100, multiply by 70 plus 1. Okay, what's that? 35.5, right? Okay, 35.5. Okay, so we should find the 35th. Okay, 35th and 36th. Okay, where are they? Yeah. Okay, so one of them is, okay, 575. Okay, that's the 35th. Okay, and the other one, 36, 575. Oh. Okay. Okay, so both of them are 575. Okay, then according to the formula, okay, we should add 575, okay, to 0.5, okay, times the difference between these two values. Okay, and it is still 575. Okay. How about 70th, 75th percentile? Okay, 75th percentile. Okay, so we divide 75 by 100 and multiply it by 71. Okay, that gives us 53.25. Okay, what should we do? Okay, we should find two values. Okay, the 53rd, okay, 625, and the 54th, okay, still 625. Okay, and find the difference between these two values and multiply by 0.25. Okay, and add it to, okay, the 53rd value, okay, 625. Okay, that's how we find 625. Okay, so the 75th percentile value is 625. And how do we interpret that? We say that, okay, at least 25% of the items take on the value, okay, greater than or equal to $625. But still 75%, okay, still another 75% of the items take on the value below $625. Okay. And how do we interpret 575? This is 50th percentile, so we say that at least 50% of the items take on the value greater than or equal to $575, and another 50%, okay, of the items take on the value below, okay, or equal to $575. Okay, how about 25th percentile? Okay, the value is 545. Okay, okay, so at least 75% of the items, okay, take on the value, okay, greater than or equal to $545. But another 25% of the items, okay, take on the value, okay, lower than or equal to $545. Okay, questions? Okay, so for this one, at least 75% of items take the value, okay, of greater than or equal to $545. Okay, but still another 25%, okay, at least 25% of items take on the value of lower than or equal to $545. Okay, that's how we interpret, okay, 25th percentile. Okay, but for 50th percentile, we say that at least 50% of the items take on the value, okay, of greater than or equal to $575. Okay, but still, another, okay, at least 50% of the items take on the value lower than or equal to $575. Okay. Okay, the 75th percentile, the value is 625. Okay, so we say that at least 25% of the items, okay, take on the value greater than or equal to $625. Okay, and at least 75% of the items, okay, take on the value, okay, lower than or equal to $625. Okay. Okay. This is the exercise. Okay. Nonoka, could you please take a picture of that? Okay, that's the exercise, okay, of today. Question 10. Okay, let's see question 10. Page 119. Okay, 119. Question 10. Okay, hard shell jacket ratings. Okay, Outdoor Gear Lab is an organization that tests outdoor gear used for climbing, camping, mountaineering, and backpacking. Suppose that the following data show the ratings of hard shell jackets based upon the breathability, durability, versatility, features, mobility, and weight of each jacket. Okay, the ratings range from 0 to 100. Okay, 0 means the lowest, 100 means the highest. Okay, so we are given 20 ratings. Okay, question A. Okay, let's find the mean, median, and mode. Question B. Okay, compute the first and the third quartile. Okay, first quartile means 25th percentile. Okay, the third quartile means 75th. Okay, 75th percentile. Okay, and then C. Compute and interpret the 90th percentile. Okay. Okay, so let's work on that together. Steve, and your name is Real. Nathan. Stephen, Nathan. Could you please work on question A? Yeah, to find the mean, median, and the mode. Okay. Nonokai and Mona will take care of question B. B, yeah. Compute the first and third quartile. Okay. And then, oh, Cai, could you please take care of C? Okay. Compute and interpret the 90th percentile. Okay. So what should we do in order to find the mean? To find the mean, the average, so we add up the 20 ratings and then divide it by 20. Okay, that's the mean. Okay, how about the median and the mode? In order to find the median and the mode, we should arrange the data from the smallest to the largest. Okay. For today's exercise, okay, let's go to iLearning. Okay, discussion forum. Okay, that's the place you upload your work. Okay. Yeah, so you see, this is today's exercise. Okay, question 10 of chapter 3. Okay, and you reply. Okay, reply. Okay. And for today's homework, actually that's last week's homework. Okay, so you go to homework assignment. Okay, here. Okay, September 20th. Okay, homework. The deadline is Friday before the TA session. Okay, and the same for the exercise. Okay, exercise is in discussion forum, and homework is in homework assignment. Okay. Questions? Yeah, this is also should be sent to iLearning, but sent to discussion forum. Okay, the lowest value should be 42, right? And largest should be 78. how do we find median? Yeah, it is in the middle. So it is the 50th percentile. Okay. Please use your cell phone to scan the QR code. Can you see that? Oh, oh, too light, too bright. Okay. Uh, Steve, Steve and Nathan, are you ready? Okay. Would you like to demonstrate your answers to the blackboard? Okay. Because there are three questions. Uh, how do you how do you divide? Because one person needs to take care of the mean, one person take cares of the median and mode. Oh, okay. Thank you. Oh, thank you, Steve and Nathan. Let's have down part A. Okay. So first, we arrange the data in an ascending order. Okay. So we start from 40 to 53, 54. Okay. All the way to 83. Okay. First, we find mean, the mean value. So we add up all the 20 values and divide it by 20. Okay. The mean value is 65.9. And then median. How do we find median? Okay, the median is the 50th percentile. Okay, so in order to find the 50th percentile, 50 over 100 multiplied by 20 plus 1, okay, which is 10.5. Okay, that's the position. Okay, so where is 10? So we should find the 10th value, 66, and the 11th, 67. Okay, so according to the formula, the 10th is 66, 11th, 67. Okay, so to find the median, +66 the difference between these two values, 67 minus 66, multiplied by 0.5. Okay, so 66 plus 0.5 multiplied by 1, that's the difference. Okay, that's how we find 66.5. Okay, median. And then mode. Which value occurs the most? Yeah, 61. It occurs 3 times. Okay, so 61 is the mode. Okay. And then Nonoka and Mona, are you ready? Okay. Okay. Question B. Okay. So Nonoka will take care of first quartile, and Mona will take care of the third quartile. Okay. Thank you. Thank you, Nonoka and Mona. Okay. First quartile actually is the 25th percentile. Okay, so we divide 25 by 100, and the sample size is 20. Okay, multiply by 21. Okay, 21 over 4, which is 5.25. Okay, that's the position. Okay, so we should find the fifth and the sixth value. The fifth is 61. The sixth is also 61. Okay, according to the formula, we first find the fifth value, 61. And then the difference between the fifth value and the sixth value, because both values are the same, the difference is 0. 0 multiplied by 0.25, okay, still 0. So the first quartile, the 25th percentile value is 61. Okay, then third quartile is 75th percentile. We divide 75 by 100, multiply by 20 plus 1, which is 63 over 4, 15.75. Okay, so we find the 15th and the 16th. Okay, 15th, 71, 16th, 71. Okay, both are the same. Okay, so we find the 15th per 71. Okay, and the difference between 71 and 71. Okay, multiply by 0.75. Okay, so the third quartile, the 75th percentile is 71. Okay, then Ai takes care of part C, 90th percentile. Okay, 90 over 100, multiplied by 21, which is 18.9. Okay, the 18th value 78, the 19th 81. Okay, the difference between these two is 3. Okay, multiply by 0.9 and add it to 78, which is 80.7. Okay, questions? Okay, so for today's exercise, please go to discussion forum. Okay, you take a picture of your work and upload your picture file, okay, to here. Okay, that's your exercise. For the homework, there are 2 questions. The first one is question 27 of chapter 2. The other one is question 42 of chapter 2. And Nonoka already took the pictures of the questions, of both questions. Okay. Okay, for your homework, you go to the homework assignment, okay, and click 2022 September 20 homework. Okay, and then you can just write down your answers on pieces of paper and take pictures of that, upload the picture file, okay, to here. So both homework and exercise are due, okay, by this Friday, September 30th, 10 o'clock a.m. Okay, questions? Okay.